In the earlier stage of network communication, TCP/IP was introduced as a standard for computer networks. Even it was developed by some university for some specific reason, it was very popular in the industry. Eventually, most of the computer and network manufacturers started using it. TCP/IP was very good, but it was not that much great. Hence, the OSI model introduced into the world. Welcome to the world of OSI model. Welcome to the CCNA 200-301, Implementing and Administering Cisco Solution, chapter number 17, OSI Model. In this chapter, we will understand about the OSI network model. We will discuss about different layers of OSI model. And we will discuss about the advantages of OSI model. Welcome to iRush Academy, an unlimited learning platform to enhance your skills. Subscribe to the channel for more videos. Now let's talk about the OSI model. What is OSI model? The word OSI stands for Open System Interconnection. The OSI model describes computing functions into a universal set of rules and standards. OSI model was introduced in 1984 by ISO. The ISO stands for the International Organization for Standardization. The OSI model consists of 7 layers. OSI model was introduced as a theoretical framework to promote standardization and conceptual clarity in networking. The OSI model is extracted from TCP/IP model to provide more standardization for the computer networks. As you can see in the screen, the OSI model has 7 layers. So let me start from the down. The layer 1 is called physical layer. The layer 2 is called data link layer. Layer 3 is called network layer. Layer 4 is called transport layer. Layer 5 is called session layer. Layer 6 is called presentation layer. And finally, the layer 7 is called application layer. Why the OSI model is categorized into 7 layers? First of all, why it is categorized into the layer? That is the main question. This is to simplify the characteristic of the network traffic. Each layer has its own function in the computer network. For example, the physical layer has some kind of functionality and which is very much different from the data link layer and other layer. On the other hand, the application layer has different kind of functionality considering the physical and data link layer. So in this way, each layer has its own functionality and each layer helps with their role in the network traffic. So in the last chapter, we talk about the TCP/IP network model. So if you didn't watch that video, you can watch to understand more about the TCP/IP network model. I have put its link on the information bar of this video at the top right. So when we talk about the TCP/IP model, it has only 4 layers available. So when we start from the down, the layer 1 is called network access layer. Layer 2 is called internet layer. Layer 3 is called transport layer. And layer 4 is called application layer. So when you compare both, you can see in OSI model there are 7 layers available. And in TCP/IP model there are 4 layers available. So the 4-layer model in TCP/IP, it is not enough to explain all the functionality of network services. So that's why the OSI model introduced to give more clarity, to make it more standardized, the computer network. Now let's have a look at the OSI model and TCP/IP model together. So here, as we mentioned, the OSI model has 7 layers and TCP/IP model has 4 layers. So starting from the bottom, the layer 1 of TCP/IP model is called network access layer. But when it comes to the OSI model, we can see this network access layer is divided into 2 layers, which is called the physical layer and data link layer. The functionality of this categories remains same. For example, what are the function the network access layer was doing in TCP/IP model? It was categorized into these 2 groups in OSI model. By doing that, we can easily understand the functionality of each network service in a simple way. Now when we go to the layer 2 of TCP/IP, which is called internet layer, it is called in OSI model as network layer. The functionality remains same. And this internet layer, sometimes it's called network layer in TCP/IP also. Now when we go to the transport layer, that means the layer 3 in TCP/IP, it is exactly mapping with the transport layer in the OSI model. Now here is the main change. The layer 4 called application layer in TCP/IP, it has been divided into 3 layers in OSI model, which is called the session layer, presentation layer and application layer. But their functionality remains same. So what are the functions this application layer was doing in TCP/IP? It was divided and categorized as 3 layers in OSI model. So these are the main differences in TCP/IP and OSI model in the case of number of layers. Now let's talk about the functions of each layer of OSI model. So we are starting from the bottom, starting from the layer 1, the physical layer. So what is the function of the physical layer? The functions of physical layer is convert the data to the form of electrical signal, that means zeros and ones. We know that the computer is working based on the binary language, and binary language contain only zeros and ones. So the any data that we are providing to the computer, it's need to be converted into zeros and ones, then only the computer can understand the data. So the function of the physical layer is here to convert the data into the form of electrical signal. It convert the data into zeros and ones so the computer can understand what is the data and it can read it. The protocol like RS-232, token ring, Ethernet and ISDN are coming under the physical layer of the OSI model. Now when we go to the layer 2, the data link layer, its function is to handle physical addressing part of the network. We know that in a network, each network device has a physical address. This physical address is used to identify the device. So when we send a data to the network, it doesn't know where to transfer that data. For that, we need to mention the physical source and destination address so that data can transfer from its source to the destination. The MAC addressing part of the devices are coming under the data link layer. The protocols like frame relay PPP ATM and fiber cables are coming under the data link layer of the OSI model. Now when we go to the layer 3, which is the network layer, and its function is to handle the logical addressing part of the network. This layer decides the source and IP address of the communication. The IP addressing part is coming under this network layer of the OSI model. The protocols like IPv4, IPv6, ICMP, IPsec, ARP, MPLS are coming as part of the network layer of the OSI model. Now let's go to the layer 4, transport layer, and its function is to handle the transport protocol and ports. When we send the data to the network, we need to decide the transport protocol and the port number. This layer manages both TCP and UDP protocols are coming under the transport layer. And when we talk about the TCP and UDP, the TCP is more reliable and UDP is more fast. So which protocol we need to use? This is decided by the operating system or the application. TCP is mainly using for the application services and UDP is mainly using for the streaming purpose. As we mentioned, TCP is very reliable protocol compared to UDP, but they are slower than the UDP. UDP is very faster than the TCP, that's why they are mainly using in audio and video communication. Now let's move to the session layer, the layer 5 of the OSI model. The function of session layer is to start and end the session. For any kind of network communication, it is mandatory to create a session between the source and destination. The session layer manages the session. It starts the session and it also ends the session accordingly. This is the least important layer dealing with the network engineer. The protocols like NetBIOS and SAP are coming under the session layer. Now go to the layer 6, the presentation layer. The function of the presentation layer is to convert the data into a generic format, translate, encrypt and decrypt the data. The presentation layer generifies the request into something that a little bit more standard so the other operating system and devices can understand. The protocol like SSL and TLS are coming under the presentation layer. It is mainly using to decrypt and encrypt the traffic. Now when we go to the layer 7 of OSI model, which is called the application layer, and its function is to manage the communication between the application and network. So when we use an application and this application need to communicate with the network to contact the server or the destination. So this is the layer that manages that communication between the application and network. This layer decides which protocol need to be used to start the communication. The protocol like SMTP, HTTPS, FTP, POP3, SNMP are coming under the application layer. So in this OSI model, the first 4 layer, which is called physical data link network and transport layer, this is the layer that is managed by a network engineer. The remaining 3 layer, that is session, presentation and application layer, are coming a part of the operating system or the application itself. So the main focus of a network engineer should be the first 4 layer. So these are the main function of each layer of the OSI model. Now let's talk about the advantages of OSI network model. What are the advantages of OSI network model? Let's discuss. So in this screen you can see the OSI network model representation into 7 layers. So one of the advantage of OSI model is the modularity and layering. The OSI model is organized into 7 layers, each representing a specific set of functions and services. This modular and layered approach make it easier to understand and design complex network system. Each layer has well-defined responsibilities, and changes to one layer don't necessarily affect the other, promoting modularity and ease of maintenance. Now the point number 2, interoperability. So what is the interoperability? The OSI model promotes interoperability by defining standard interfaces between each layer. This allows for the development of network protocol and devices independently, as long as they adhere to specific interfaces. Interoperability is crucial for the coexistence of different vendor equipment and technologies. Now point number 3, standardization. The OSI model is an international standard developed by the International Organization for the Standardization, that is called the ISO. Its widespread adoption helps in creation a common language and understanding most network professionals globally. This standardization facilitates communication and collaborate in the development and maintenance of network system. Now point number 4, ease of troubleshooting. So how the OSI model helps to troubleshoot easily for the network engineer. The layered structure of the OSI model make it easier to troubleshoot network issue. Problem can often be isolated to a specific layer, allowing network administrator to focus on a particular area without having to understand the entire system. This accelerates the diagnostic and resolution process very easily. That means if there is an issue in one layer of the OSI model, the network engineer can concentrate on that layer and resolve the issue accordingly. It doesn't have any dependency or doesn't have to check anything in the other layer. For example, if there is a connectivity issue, the engineer can focus on the physical layer because the physical layer is the one who manages the connectivity. And if there is an IP address issue, they can concentrate on the network. If there is a MAC address issue or protocol issue, they can concentrate on the data link layer of the OSI model. Now point number 5, educational tool. Yes, that's right. The OSI model is widely used in educational setting to each networking concept. Its layered structure provides a systematic and logical approach for students to learn about different aspects of networking, from physical transmission to application level interactions. Now point number 6, facilitate vendor neutral discussion. As an abstract model, the OSI framework allows for vendor neutral discussion about networking concepts. Professionals can discuss networking protocols and technologies without being tied to a specific or any particular vendor's implementation. Now point number 7, future proofing. So what is future proofing? The OSI model was designed to be a comprehensive and flexible framework. While it may not have seen widespread practical implementation, its conceptual design allows for the incorporation of the new technologies and protocols as they emerge. This adaptability contributes to the model's longevity and relevance. So in this chapter, we have understood the OSI network model. We have discussed about different layers of OSI model. And finally, we have discussed about the advantages of the OSI model. Thank you for watching, and subscribe to the channel for more videos.